Shopping trolleys are commonly provided in supermarkets to help customers transport heavy items. However, they are rarely available in morning markets, even though customers also purchase heavy goods. This raises the questions, why do authorities not provide shopping trolleys in morning markets, while the same facility is commonly available in supermarkets? This is our video experiment. This is our collected data for our experiment. Based on our data collections, the trolley was tested on two different surfaces, which are mosaic and tar, with the same distance of 4.76 meters. Without load, the trolley took 8.18 seconds on the mosaic surface and 8.81 seconds on the tar surface. When a load was added, the time increased to 9.00 seconds on mosaic and 10.25 seconds on tar. From the results, the trolley moved fastest on the mosaic surface and slow on the tar surface, especially when carrying a load. This shows that the type of surface effects of movement of the trolley and may explain why shopping trolleys are commonly used in shopping malls but not in morning markets.
Next, I will proceed with the calculation. So first, we will calculate the velocity of the trolley using the velocity formula, which is V equals to S over T, where V is velocity, S is distance, and T is time. For the mosaic surface, V equals to 4.76 divided by 9.00, and we got V equals to 0.529 meters per second. For the tar road surface, V equals to 4.76 divided by 10.23, and we will got V equals to 0.465 meters per second. So based on the calculation, the trolley travels the same distance of 4.76 meters on both surfaces. However, the velocity on the tar road was lower than that on the mosaic surface. This indicates that the trolley moved more slowly on the tar road surface. Next, we identify the forces acting on the trolley using a free body diagram. The trolley experiences four forces. First, the applied force F sub P, which pushes the trolley forward. Second, the friction force F sub F, which acts opposite to the direction of motion. Third, the normal force N, which acts upward from the surface. Lastly, the weight W acts downward due to gravity. These forces help us analyze the motion of the trolley before calculating friction force and applying the Newton's second law. To calculate the friction force, we first determine the normal force, which is the formula is N normal force equals to M mass times with G, the gravitational acceleration. So N equals to 4p3 times with 9.81. And we got N equals 421.83 newtons. For the mosaic surface, the coefficient of friction is given 0.42, while for the tar road surface, the average coefficient of friction is 0.75. Next, sub F friction force equals mu coefficient of friction times with N normal force. So F sub F equals to 0.42 times with 421.83, and we got F sub F equals to 177.17 newtons. For the tar surface, F sub F equals to 0.75 times 421.83, and we got F sub F equals to 316.37 newtons. The tar road produced a larger friction force of 316.37 1.37 newtons compared to 177.17 newtons on the mosaic surface. Therefore, the trolley experienced greater resistance on the tar road surface. As a result, the trolley moved more slowly on the tar road compared to the mosaic surface.
Now, we apply Newton's second law to analyze the motion of the trolley. Before we performing the calculations, we first draw a free body diagram to identify all forces acting on the trolley. The trolley still experiences 4 forces, which is normal forces, going upward from the surface. Second is the weight, going down due to the gravity. Third, the applied force, Fp, acts to the right, which the trolley going forward. And lastly, friction force, Ff, the opposite motion of the trolley. Since the trolley does not move vertically, the forces in y-axis are balanced, which normal force equal to the weight. For the horizontal direction, Newton's second law is applied, which summation of Fx equal to ma. We move to the calculation part for mosaic surface using Newton's second law. But first, we have to determine the acceleration. We use the formula A equals to 2s over t squared to find the acceleration. We substitute the values. A equals to 2 times 4.76 over 9 squared. Then we get A equals to 0.118 meter per second squared. Next, we apply Newton's second law, F equals to ma. We substitute the value to the equation. F equals to 43 times 0.118. Then we get the answer F equals to 5.07 newtons. Next, we calculate the tar road surface. We substitute the value to the formula for acceleration. A equals to 2 times 4.76 over 10.23 squared. And we get the answer A equals to 0.091 meter per second squared. After that, we apply to the Newton's second law formula and we substitute the values. F equals to 43 times 0.091 and the forces we get 3.913 newtons. According to Newton's second law, the greater friction force on the tar road reduces the trolley's acceleration, causing it to move more slow. Therefore, the tar road surface may be one of the factors affecting the practicality of providing trolleys at the Pasar Pagi. This table summarizes all the results obtained from the experiment. As we can see from the results, the tar road surface produced the highest friction force and the lowest acceleration. Therefore, the trolley moves slowly on the tar road compared to the mosaic surface.
Now I will explain the trade-off in choosing floor surfaces. Based on our experiment, the mosaic floor allows the trolley to move faster and require less force to push. This makes it more comfortable for user. However, the mosaic floor has a higher installation and maintenance cost. For the tar road surface, it is more durable and cheaper to install. It is also suitable for outdoor areas, but it creates more friction, so users need more effort to push the trolley. Therefore, each surface has its own advantages and disadvantages. So, what the impact on user? The floor surface affects users directly. A smoother surface helps reduce physical effort, increases comfort, and is helpful for elderly users or people carrying heavy loads. It also reduces tiredness and makes using the trolley easy. Next, we look at the environmental and sustainability impact. A smoother floor surface reduces wear and tear on trolley wheels. This lowers maintenance costs and helps the trolley last longer. It also reduces material waste because fewer parts need to be replaced. Our recommendation is based on 3 values. First, responsibility, which means providing a safe and comfortable environment for users. Second, fairness, ensuring everyone can use the trolley easily regardless of age or physical ability. Third, sustainability, by choosing a solution that reduces waste and long-term costs. Therefore, we recommend the mosaic floor because it provides better performance, comfort, and long-term benefit.
Last but not least, we move to the conclusion part. Due to lower friction, the trolley achieves higher acceleration on the mosaic surface. Higher friction on the tar road requires more force and effort to push the trolley. Therefore, Smoother surfaces are more efficient for trolley movement than rough surfaces. From this experiment, we can see that the type of surface affects how easily a shopping trolley moves. This is also the reason providing the trolley at the Pasar Pagi are not efficient, because it can increase the spending cost and also damage on the trolley itself. All in all, we can see the disadvantages in terms of physics and budget costs.